The subsurface is only half of the story of a geothermal energy system. Heat delivered to the surface must drive a turbine to produce electrons for the grid. There are a variety of ways heat is leveraged into electrons currently, including flash steam, dry steam, and the binary Organic Rankine Cycle systems. But there is broad agreement that in order to drive down the cost of geothermal energy production, optimizing and increasing efficiency in both the surface and subsurface systems will be required. So, how do the surface systems currently in use in the industry function? How might these systems be improved upon with an eye to driving down cost? And what areas are ripe for innovation? Let's explore.
Welcome, everybody. This is the Contemporary Topsides Geothermal Power Production Panel, and we're extremely fortunate today to have a great group, a diverse group of individuals able to join us to talk about this technology. My name is Nick Goodman. I'm the CEO of Circ Energy. Circ is a US-based developer, owner, and operator of geothermal plants, primarily binary, with one flash plant in the Salton Sea area in California. And I'm very pleased to be able to moderate this session today. As I mentioned earlier, we have a diverse group of industry veterans with both above ground and below ground experience. While the title of our session today is Contemporary Topsides, one of the rules, at least that I learned early on in the industry, was disconnecting the resource and the topside generation too much leads to challenges. We like to try and integrate them at Circ. So we will be talking a little bit today about how the below ground impacts and interacts with the above ground with regards to operations and technology and the likes. And some of the folks on the phone have some good background there. So appreciate everybody joining in today. It's a fabulous conference underway. Kudos to Jamie and her team for getting this all structured. And we're going to go ahead and kick it off with introductions to the other panel members. So with that, if we could bring the other panel members live. And Paolo, I'll start with you. Do you want to give a brief introduction on yourself and your company?
Yes. Thank you, Nick. And my name is Paolo Bertuzzi. I am the CEO of Turboden. We are an Italian-based company, part of Mitsubishi Heavy Industry Japan. We have been established in 1980, and from that day, we are always focused on organic Rankine cycle design, installation, commissioning, and after service. This technology can be used for several different renewable applications, biomass, and mainly geothermal, and also waste heat recovery from industrial heat and also oil and gas. I'm very honored to be here and to discuss with you and my colleagues.
Great. Thank you very much, Paolo. Patrick, we'll kick it to you.
Hi, good morning. My name is Patrick Walsh. I'm the Vice President for Geothermal Resource at Ormath. We're a vertically integrated company with a 1,000 megawatt geothermal portfolio that's growing. I have a pretty strong subsurface focus, as you mentioned, and experience in acquisitions, greenfield exploration, reservoir management, and drilling, especially on the safety side. I think the geothermal industry is really poised for a breakout, and it's one of those, 30 years of hard work toward an overnight success, and I think that's where we are. So really excited to be here, and thanks to Jamie and the other organizers for putting on the conference.
Super. Thanks, Patrick. Taylor Maddie from Baker Hughes, could you introduce yourself?
Yeah, hi everyone. I'm Taylor Maddie. I'm the Geothermal Innovations Leader for Baker Hughes. It's where I develop the global strategy for organic and inorganic technology development in the geothermal space. My role is to bridge the gap between oil and gas and geothermal via technology, investments, partnerships, with the goal of growing the geothermal industry as a whole and our leadership positions within it. I'm real happy to be here and on this panel and sharing it with these colleagues here.
Great. Thanks, Taylor. And last but not least, Jörg Udi, who I think is joining us from Germany. Jörg, would you like to introduce yourself?
Thank you, Nick. Well, my name is Jörg Udi. I'm the CEO of Volkswagen GeoFuture. Limited. We are operating for a decade, the second ORC geothermal power plant in the Upper Rhine-Graben, so which is in the southwestern area of Germany. It's the second generation. Our predecessor was probably well-known Landau geothermal power plant. And we are very proud that we have a very successful and stable production on our side. And what is the main demands we have to face is to mitigate induced seismicity that this occasionally occurs in the Upper Rhine-Graben, and we have a very sensitive public in our particular area, so we have to respect it. I'm as well very happy that I might be discuss all these topics together with all of you tonight.
Super, thank you, Jörg. So that's our panel, and maybe to kick things off, it'd be good to start with a little bit of a discussion about generation technology today. What's the current status? I call this the binary versus flash discussion, perhaps. I think we're a little biased towards binary on this panel, although I know Patrick, hopefully you and Jörg and Taylor can also, and Paolo can all speak to flash technology as well. But perhaps just an introduction on your company and your involvement with generation today. What you see are the positives and the negatives, and what directions you think you and your company are trying to head. Patrick, why don't we start with you, if that's okay?
Okay. Yeah, so we have a mix in our portfolio of flash plants and binary. I will say that, you know, most of the new plants we build are binary, except for some potential future very high temperature things. And part of the reason for that is the flexibility. What we've done over the last really 30 years is increased the turbine size and the efficiency of those binary plants. So I know this audience is probably has a full range within the industry of, you know, very limited experience to very experienced. So the simple way to put it is we use hot fluids to boil a secondary fluid. This is the binary technology. And that secondary fluid, which there are several choices for, turns a turbine, and that turbine then generates power. So by starting, you know, again, 30 years or so ago with small, call them 2 megawatt turbines, we've slowly increased those, and now we can generate a lot of power from a single turbine, with some really great examples in New Zealand where we've used binary to generate 25 megawatts or so with a single turbine, and we've even increased the sizes since then. So that's one of the big improvements we've made. And then all along, we're constantly doing small tweaks to improve the efficiency. So things with the cooling towers and various other aspects that I'll maybe let the others talk about to improve efficiency and make binary more competitive. And for us, the main advantage there is we re-inject 100% of the fluid. So we're balancing pressure within the reservoir. And then, you know, there can be some cooling issues because really what we're doing is mining heat. And when you use a flash plant, you're removing fluid from the system, and there are some well-publicized locations where that drawdown of pressure in the reservoir has led to large declines. So within the reservoirs, we're always balancing temperature and pressure within the fluids. And from my standpoint, being able to inject all the fluid, choose where it goes, is the big advantage of binary over flash plants where you can use it.
Super. Thanks for that, and yes, thanks for helping folks out with how binary works. We do have, I think, a very wide range of experiences and skill sets likely listening in today. So a little bit of education is very helpful. Taylor, can we flip to you? Can I put you on the spot to talk a little bit about the flash side of the industry? And I know Baker Hughes, I believe, still has access to flash turbines from GE.
Yeah, we do. So we retained our turbine division when we separated from GE. That was based on Miller Pignone in Italy. And it's probably unknown to most people in the audience that Baker Hughes actually does have turbines running for geothermal power, most notably of which is in Lauderdale and then a few in Central America. So, you know, right now our product portfolio is focused on steam turbines, but we're really looking to expand that in the next couple of years and change our position with how we support geothermal for the benefit of the geothermal industry. And so a lot of thought and commitment is being worked on to go into new technology to support that space. So right now our turbines are mainly designed for like natural gas, you know, very high enthalpy high pressure, high temperature applications, but are suitable for geothermal. And we're really looking to support, how the development of binary systems are coming online, especially with regards to modularity, which we see as being very key to new market developments, especially with like microgrid technology, EGS, AGS, and how it just impacts the cash flow for projects while they're in development.
Super, very helpful. Thank you. Paolo, to you, Turboden, as I know, is primarily a developer or a manufacturer of binary technology, but you have the relationship with the mothership in Japan who makes the flash turbine. What is coming down the pike? What's in the future for generation that excites you in geothermal? What advances or directions do you see coming with regards to generation?
Thank you, Nick. Yes, in fact, our company is focused only on binary solution for power generation, but we are part of Mitsubishi Heavy Industry, and they are one of the leading company for flash solution in geothermal. We think that both technologies has advantages and disadvantages, of course. And but what we can see is that binary is the fastest growing technology. So if you look the last years, most of the installed capacity is based on binary. But I think that a combination of the two technology can work and can work well, both for greenfield, also for retrofitting of all the projects, because if we really want to avoid the CO2 emission, we also need to focus on how to maximize the production out of existing wells in order not to drill wells when it's not needed. So there is a very large untapped capacity of brine after the separation for flash projects. So in all the flash projects, the brine is not used. So you get from the earth a mix of water and steam. You separate the water from the steam. You feed the flash with the steam, but you still have the brine. But today typically is reinjected without use. What is coming on is the possibility and the interest of many of these large companies that already has existing cash flow coming from flash to retrofit the existing project with a binary solution. This is something that we are promoting, and also I think Ormat and other players are of course targeting this interesting market. As well as another point is that most of the time there are some reduction of capacity in all the flash system because the temperature or the flow is reduced during the life of the project. So study the possibility to convert a very old flash project into binary is also an interesting opportunity that we can discuss with customers of MHI or the flash, as well as of other flash technology. So I think that we should keep our eyes open to the possibility to combine flash and ORC, and knowing the advantage of both systems. And I fully agree, of course, with Patrick about the importance of the full reinjection. Full reinjection keep the reservoir in a more stable condition, and also to avoid the use of water, in my opinion, for the cooling, because at the end also water is becoming a very limited resource. So ORC offer the possibility of full injection from one side and no use of water in case you use direct ACC condensation.
Very good. Thank you.
I think maybe, sorry, before we move on, just to follow on what Paolo said, in the interest of reducing the number of wells or maximizing the wells, we're also putting pumps in wells. You know, we use ESPs for smaller diameter wells, like you said, sometimes existing wells. And we drill very large diameter wells for new fields with 16-inch production casing, and we've developed pumps that can have very high flow rates. And so again, with the interest of minimizing the number of wells we drill, maximizing the amount of energy we get out, we're using pumps throughout our fleet. I would say more than 2/3 of our wells now have pumps in them, and some of them very large pumps. And that's something we work with Baker and others on, as well as Ormat pumps that we've developed and started to sell.
Good point, Patrick. And maybe a good transition to you, Jörg. I know in Germany you drill quite deep and generally are with binary. Can you talk a little bit about generation technology, and including maybe how district heating or a secondary heating usage is playing out in Europe, and also tie in maybe this concept of reinjection and the environmental concerns with geothermal overall, which is also a concern I know in Europe.
Well, in Central Europe, so this is not only Germany, but as well the adjacent countries, Austria and then France and the West. We are working in low enthalpy geothermal fields. That's why we can use binary technologies only. For example, in the most developed geothermal play in Bavaria and the Munich Basin, actually about 6 or 7 binary plants are under operation, probably 3 or 4 to come in the near future. But the most promising geothermal field will, from my personal view, the Upper Rhine Graben, which stretches over from northeastern France to western Germany, where we actually have a pipeline of about 15 projects under development and 4 to 5 in operation, including ours. Especially in the Rheingraben, we have to drill quite deep to reservoir depths of 4 to 5 kilometers, gaining reservoir temperatures about 160 to almost 200 degrees Celsius. But we have fairly low flow rates in the Upper Rheingraben. The average flow rate in the Upper Rheingraben stretch from 60 to 100 liters per second. In comparison to that, in the Molasse Basin in Munich, we have higher flow rates, but lower temperatures there. So basically the energy output in these places is not that much different. But the most productive wells reach production rates of about 200 liters per second. And from my personal view, I believe that we will come over in Germany or in Central Europe as well to multiple well projects. As actually we only operating doublets or even triplets. This is not enough to produce enough flow rate for the future. All these developments are based on a feed-in tariff, which is guaranteed for 20 years. We discussed it already, Nick, of a 250 megawatt gross subsidizing, which will exceed from now within the next 20 years. So the main demand for all these operators will be to optimize their levelized cost of energy to then market values, which will be far lower. We expect in 10 or 15 years, market prices in Central Europe, about 100 euros per megawatt hour. So there's a lot to do to optimize and to realize additional incomes, for example, to extract heat for district heating projects or greenhouse projects. There are some examples already existing who are doing so. Or what as well could be especially interesting in the Upper Rheingraben, we have an interesting lithium content in our brines, which is not far different from what you find in the Salton Sea area. And actually we have a so-called lithium rush in the Upper Rheingraben, where a lot of project developers intending to develop their geothermal projects. The startup will be again subsidized from this guaranteed feed-in tariff. By this project development will be financed and to make the brine available for lithium production above ground. So a very promising and interesting future will come from my point of view. And as well, we need, especially in the Rheingraben, the line shaft pumps Patrick already mentioned. Due to the fairly high brine temperatures, we cannot operate ESPs there. So we have to install line shaft pumps, which is a technology which is now very reliable, and we are very happy to operate those now.
Good, thank you, Jörg. Picking up on this construct of lower temperature, and this is a question that's come in, can we expand ORC systems to generate electricity at lower temperatures? Paolo, maybe to you and to Patrick as well. How are you thinking about lower temperature geothermal and its capability of expanding significantly the number of geothermal resources we can focus on?
We think that, of course, ORC is the proper technology to generate power also from low temperature, but low temperature heat and water. Of course, it depends on the external temperature of the air, because that's the balance. We believe that 100 degrees remain the lower temperature of the brine to really produce power from an economic point of view. So we have some running unit at a lower temperature, 90, 92, one in Austria, very old, but we believe that below 100 degrees, it's very difficult to have a real economic sense of the production. And on the contrary, I'm very much interested in the combination of power and heat in geothermal, as I was telling before. Several of our units installed in Germany, in the Bavaria region, in fact, are running in combination with district heating. So from a power plant point of view, if you know that there is this interest, you have to design the system in order to be flexible and in order to give the possibility to change the mode of use also during the life of the project, because typically the power generation is fixed from the beginning, but the district heating is something evolving, because typically all the district heating have a continuous increase of heat demand, because typically new buildings, new industry then are connected. So you need to design in a flexible way. And for example, you can design the system with 2 cycles and extract the heat after the first cycle if the injection temperature is too low to feed a district heater. So some of our solutions are based on this concept. Another point that we are developing is the possibility to combine ORC and large heat pump. So we think that electrification of the heat, green electrification of the heat, is one of the real driver of the growth. Because if we look only power generation, at the end we go in direct competition with other renewable sources that maybe are more easy to be installed. But if you consider the combination of heat and power, on the contrary, geothermal can really have a big advantage, and also the feasibility of the projects is increased, and also the possible lifetime of the project can be longer, because when you finish the feed-in tariff, you still get the heat available. And typically district heating are designed and installed to have a very long life.
Very good. Patrick, lower temperature, pushing the envelope at all, and other uses, district heating, greenhouses, the likes. What are you seeing at Ormat?
So I would say we're focused pretty uniquely on electricity generation. So we have pushed the envelope on what can be done at a relatively large utility scale. So I'll say when I came to Ormat about 13 years ago, we were really focused on 150C and above. And as we continued to push the technology and call it lower temperature reservoirs, we're now producing less than 130C and producing tens of megawatts from a single field with that. So we've been really, again, trying to hone in on that, call it 130C to 220C range, because of the relatively high output you can get. I like the idea of district heating, but we're not terribly involved with it currently, partially because where our business has focused, I think, there's not a significant incentive for it. You have to have, essentially an off-taker. We talk about off-takers for electricity generation. The same is true with district heating. There has to be someone to use that flow of somewhat cooled fluid. And typically, we haven't had very many off-takers for that.
Understood. Certainly our experience here in the U.S. as well. Taylor, over to you. With regards to these lower temperature and expanding industry in Europe and elsewhere, perhaps, part of it is temperature and part of it is how do we move this fluid to the surface. Can you talk a little bit about pumping, ESPs versus line shaft, and how that plays into a power plant versus maybe a district heating utility or both?
Yeah, certainly. So, I mean, there's certainly pros and cons for both technology when you're talking line shaft pumps versus ESPs. And there's restrictions that you have for both of them. So for the past about 10, 12 years, Baker Hughes actually has been partnered with the German government and then receiving funding for the development of high temperature geothermal ESPs, which are being used in Bavaria and the Netherlands for district heating, Bavarian power plants for power generation. So I think we actually have some pumps going up to Paolo's turbines in a couple different areas down there. So, we've been developing the technology for really high temperature and reliable ESPs that can operate in the extremely harsh conditions that you find within geothermal wells. But when it comes to like the higher temperature stuff, there's a bit of a window, because we can't push the temperature limits of downhole electronics too long without having considerations with the reliability of the systems. So in most cases, you're going to have a pump that's supplying fluid to a binary plant, because after about 180, 190 C, you start to have issues with the electrical integrity of the system to obtain a long run life of an ESP. And that's really what the advantage of the LSPs are, and being able to have just mechanical parts downhole that require lubrication is you don't have any of the electronics that are going to be damaged over a long period in really hot temperatures. So there's applications for both. There's situations for both. But in any case, as it relates to turbines, it's almost always going to be going to a binary plant, just because if you have a pump that's producing something that's going to be flashed to steam in most cases, you almost just flow the well on its own, and you won't need to have any sort of artificial lift method. And we find that most district heating applications as well in Europe require some kind of pumping application. Those typically flow at lower temperatures. And so you can expect, really healthy lives for the ESPs that are installed or the LSPs that are installed there.
Interesting. Jörg, as we look to expand geothermal, certainly low temperature, it strikes me that there's the potential to get closer to population areas. Traditionally, at least here in the US and in many places around the world, geothermal plants have been fairly remote, and as a result, another hurdle for district heating. In Europe, not so much the case as projects are developing. Can you talk a little bit about the current technology for both generation and district heating, and what are the challenges with developing in existing communities or near communities, environmental, seismic, things like that you're experiencing in Germany and elsewhere in Europe?
Well, we have to close the gap between the conflict with public criticism. If we have major concerns about induced seismicity, especially in the upper Rhine-Graben area. But of course, once you have understood how to safely operate a geothermal brine circuit, there is no risk for the public. And Paolo, for example, has experienced this with the close-by project in northeastern France, but unfortunately has been suspended by the authorities due to, fairly high induced seismicity. Probably the reservoir development failed in a certain way. And this, of course, has an influence and has a consequence for us on the close-by southwestern area. So what will be the solution? And we experience this from our reservoir. If we have a multilateral reservoir development, we have a sidetrack in our reinjection well. So we do not face induced seismicity effects while reinjecting the brine, but which was a learning effect even for the seismologists who are supporting us, that we only have induced seismicity on the production side. And the actual idea is, together with other partners as well, I'm looking at Taylor's, to find a proper solution to establish this multilateral reservoir development as a standard solution for further geothermal projects, as for several reasons, not only to mitigate induced seismicity, but as well to enhance the production rate by this development technology overall, as it's more efficient than drilling multiple ways. Of course, you may understand on the production side, you still only need one production pump instead of several production pumps if you operate a multiple ways site. So this is the situation we have to face when developing geothermal projects in a very densely populated environment, as we do have, of course, in Central Europe. But on the other side, we have the advantage that we will be able to develop heat sinks for the future, as our colleagues already mentioned. Once the feed and tariff subsidization will have inspired in a couple of years, we have to generate additional incomes, and extracting heat in combination with a continuing power production will be the solution for the future, I believe.
Very good, thank you. Patrick, maybe over to you. We're talking a lot about below ground. Why don't we go there directly? What's new on the drilling side? I think as we look at the evolution of solar and wind pricing, we've seen considerable improvement on equipment pricing, and I think everybody can get their arms around or have their own opinions on equipment pricing and geothermal, but drilling has not changed a lot in the last however many years in our country. What are your thoughts there in terms of how we advance things going down the road?
I think it's a good question. It is something that we're involved with, especially with DOE and NREL research. You're right, it hasn't changed very much. I think someone touched on the multilateral, and we have done some drilling where you drill a surface location and have 2 or 3 legs from the same. For us, we've done that typically on the injection side. So we're trying to distribute the injection to reduce cooling, and also increase the total flow that the well will take. So for us, that was a bit of a step forward. Obviously, the oil and gas industry has had a huge, really well-publicized success of improving technology, and we do try to take that technology from them. I should start off, as soon as you ask about drilling, and I think I touched on earlier, that safety for me is always the first thing. If people are not getting hurt, it's the most important thing that we have. And I think the kinds of safety programs that oil and gas also have spearheaded in the last 20 years have been really important for us in drilling. Part of that does touch on costs, because if the rig's not shutting down, what we call flat time, the time that you're not making whole, is actually one of the biggest costs we have. And so reducing flat time is, for us, the first priority. As far as drilling technologies, the costs are to some degree fixed. We have casing and cement that are market prices and don't change a lot. So what you can do is reduce flat time and increase drilling rates. So, the work that Sandia and others have done with PDC bits and is currently being done in the Forge projects in Utah is very helpful for us, because they really are research projects focused on improving drilling. And we're taking everything we can to reduce our drilling costs and drilling times based on that. In terms of specific technologies, again, there's a lot of research happening, everything from lasers and with ablation to, like I said, those PDC bits and hybrids are all things that we can take away from. But for us, it is a little bit basic. We're trying to reduce flat time and reduce the number of days it costs to drill a well. That's the simplest way to put it.
Interesting. Thank you. Taylor, go ahead. Drilling and specifically the role that oil and gas might play in supporting the advancement of geothermal drilling.
Yeah, so totally agree with what Patrick said. It's not necessarily the technology that's out there that's going to be significantly increasing the ROP for these geothermal wells. I mean, of course, that does help, but it's really about how to reduce that flat time. And what that boils down to is how to increase tool life. And so there's a lot of technology being developed and technology that's being deployed right now that is what you might recognize as being the same shape and form as what we've been running for years, but different materials, different techniques, different software that's being used to control the equipment is reducing the amount of time that you have to, or the number of trips that you have to make in a well. So, you know, that significantly has a huge return on the reduction of your AFE, on the pace that you're able to get production online. So, you know, it's either going with increased tool life or with, you know, these new plasma drilling technologies or millimeter wave drilling technologies. And, you know, they have merit, but it's just a matter of finding which one is the correct one and which one can be done economically and where. I think to kind of expand on the comment behind drilling and economics as a whole, and to the theme that you mentioned at the beginning of the panel, Nick, which is making sure that you're connecting the reservoir to the turbine. It's very critical to look at the development of a project systematically and simultaneously. And so what I mean by that is from the very inception of a project, there needs to be a direct connection between the reservoir simulation, the feasibility analysis, with what the turbine output production is planned to be and capable of being based on the reservoir. And that's something that, you know, we've actually been working on quite a bit because we have this portfolio that expands from feasibility and reservoir all the way to turbines, is connecting these two together as a unique, you know, value proposition to the industry. Because the idea is that, you know, if you know exactly what your reservoir is going to output and you're confident in it, you can have a turbine that's going to be sized specifically for whatever your reservoir output is. And then in the middle piece, have your wellbore size specifically for whatever the turbine requirement is. So therefore, you're not going to be oversizing or undersizing a turbine or a binary plant. And you're really going to have the most optimal CapEx spend for your projects. And then in the long run, you know, using software for reservoir management as well to make sure you're getting the most out of your field. And all of that, you know, it's a little bit far-fetched from where we started with drill bits, but it's important to keep in context that it's not just drilling that's needed to reduce the capital for these projects, but it's really like a holistic view and holistic execution of a project in order to make the economics of these projects feasible.
Very good. Thanks, Taylor. Paolo, back to you. Moving back above ground, we have a few questions coming in on modularity, the ability to build these plants modularly, presumably off-site, and then installing them much more quickly and presumably more cheaply. Thoughts on that, both at Turboden and just in general?
Thank you. It's a very good question. There is always a trade-off between modularity and the tailor-made solution to extract the last possible kilowatt. Okay, and I think that there are some components of the ORC that has to be modular designed and modular produced, like for example the ACC base. So if you have an air-cooled condenser, you can size the air condenser based off a different number of modular base, and so you can standardize this component. Similarly, also on the pumps, internal pumps of the cycle, so not geothermal pump, but the cycle working fluid pump, or also on some heat exchanger, you can, for example, pre-design this heat exchanger. The aim should be to reduce the design period and also the execution period, because typically the real question is, do we wait to know the exact condition of the water, temperature, flow rate, composition, or we can start designing and producing the ORC in parallel with the test of the wells and this. So we are working in the direction of modularity, and for sure also Orbat is having large scale production. But at the same time, we know that when the temperature of the water is relatively low, we are talking about 120, 130 degrees, a few degrees of temperature make a big difference in the thermodynamic cycle. So if you design a tailor-made solution, you can really extract a larger efficiency, because you work on a cycle that has a low temperature delta between the heat source and the cooling side. So it's a real balance between modularity and a custom-made solution. And if you can work well in this selection, you can offer the best solution.
Interesting, thank you. Jörg, are you seeing construction and installation costs as a barrier to more geothermal development, and would modular installation be a source of reducing costs, in your opinion? Oops, I think you're on mute, Jörg.
Yes, sorry, thank you. I'm sorry. Well, we have to face more extremely high drilling costs in Central Europe as due to very strict environmental regulations, and as a consequence of some environmental accidents which have occurred not only in geothermal but as well in oil and gas wells in the last years. The mining authorities are actually about to set up a so-called well inspectorate. So it will be something like a well police we will have installed in Germany, and therefore well integrity is key for the future. So we have to focus on developing long-lasting wells. Of course, this is a financial issue we have to face, that as it's the highest investment in our geothermal projects, the wells. You may estimates drilling costs about 3 to 4 million euros per kilometer for a geothermal well due to the higher diameters, as Patrick already mentioned, we have to realize. So this is the fairly highest investment, and it's covered with a very high risk, as we still have the finder's risk. So there are a lot of wells in Germany which have turned out to be dry. Actually, the most recent project in southeastern Bavaria turned out not to be successful, even if they had a very precise and proper reservoir development. By the end, the wells have turned out to be dry, which is really a mess for the whole industry. But as well, coming back to your question, well, a modular design of the ORC units could be very interesting in those cases where we have a combined heat and power production. And therefore, depending on the project development over time, it could be of major interest to add modular systems on the ORC side once the initially expected heat demand could not be covered.
Very good. Patrick, a question for you, sort of related, I guess, to the prior with regards to price. What is the current, on average, cost for installing a plant? Why don't we just say equipment above ground and leave the drilling out of it, since that's a pretty wide-ranging depending on the project. But where are you guys at Ormat in terms of a range, and where do you plan to be heading in terms of?
It's a good question. To be honest, my background is much more able to talk about subsurface costs than construction costs. I mean, I hear them, but they are really, if you build a 10 megawatt plant or 100 megawatt plant, this is a huge cost. And so it really is, as Paulo said, it's very unique to the location. I think for us, one of the things when we talk about technology and what we're doing is we're taking the risk out of it to some degree by building power plants that are a little bit too small for the reservoir. So rather than build something that maximizes what we think is there, we tend to actually take a smaller bite, maybe call it 50%, whatever the number is, build a power plant and see how it runs for 6 months to a year, and then do expansion. So what you'll see is for many of Ormat's power plants, we've built 2 or 3 power plants in the same location as we make sure that the reservoir can support it. In terms of cost, honestly, I didn't come prepared to talk about a per megawatt cost. So I can talk about well costs and things, but I'm not directly involved with building power plant.
Two good takeaways. I think your last point, and I guess McGinnis Hills would be a great example of that, where you've built, started small and increased over time, and as opposed to, I think, a number of mistakes made in the industry where folks size projects at the absolute max and then had trouble backfilling with the drilling. So
yeah, McGinnis and Alcaria for sure. We've done the same. Alcaria started as a 10 megawatt plant in 2000, and now is in the 150 megawatt range after many years of development. Right.
Two good examples, and avoided some of the challenges that other projects have. Paulo, directions that you're trying to steer the company with regards to either reducing cost of equipment or reducing cost of the project through, some alternative schemes that Patrick raised?
Yes, thank you, Nick. Of course, the reduction of cost of the CapEx is a driver that we all need to follow, also to compete, to make geothermal competitive with other technology that are on a production curve that has a much bigger volume, like PV or wind. For sure, as also Patrick mentioned before, increasing the size of the unit, it's a good driver to reduce the cost per kilowatt of the installed capacity. So we are also moving in this direction. Now our largest single turbine is in the range of 20-25 megawatt. And if you combine two turbines together with a single generator, double shaft, you can move up to 40-45. So you arrive to a size of project that is start becoming important, and you can do multiple projects. So the increase the size is for sure a good way to reduce the cost, but it's not, of course, the only one. Another point is to try to use a modular design, as we discussed before, also because the reduction of the lead time at the end is a big reduction of cost in the feasibility of these geothermal developers, because differently from other technology, when a geothermal developer orders you an ORC, typically a binary, he already invested several millions dollars or euro in the drilling. So the shortest is the let's say the delivery time, but not only the delivery, the timing to arrive to commercial operation, and the sooner he start getting some cash flow and to repay. And in this sense, what Patrick was saying, to start with a reasonable size and then increase the size of the project later, make also sense from a cash flow point of view, to start giving cash to the customer in a period where they need to start repaying the debt and the most critical financial part. Okay. I think that if you the cost of the capex is very different area by area, and also is influenced from the efficiency that you target. Because if the tariff is very high, like in Germany or in Japan, for example, you need to extract the highest possible efficiency from the resource. No? And so if the cost of drilling is high and the tariff is high, you try to maximize the efficiency. So for example, you do a very large cooling system, so the capex per kilowatt installed increase. If on the contrary, the price of the feeding tariff or the electricity is not very high and the drilling cost is not very high, you have a different optimization model, like for example in Turkey or probably also in certain area in US. So it's difficult to talk about a installed cost of kilowatt. Typically, you can assume $3,000 per kilowatt installed, not considering the civil works.
So thank you, Paolo. That's helpful. Maybe just to quickly around the horn, what are we seeing as timelines to get a project from conceptualization to commissioning online? Maybe Jörg, starting with you. What are you seeing in Europe? How long are projects taking to develop?
Well,
I think that, sorry.
So this may differ, of course. If you have a very geothermal friendly environment, as we find it in Bavaria, you may be able to develop a project from sketch into final operation within a period of 4, maybe even 5 years. Probably this will take a little bit longer in the upper Rhine-Graben, as we have very critical and difficult discussions with public acceptance. So 4 years for a project development is a very optimistic period of time. And maybe I might add something to your cost question. So we learned that we have a capex of around 10 million per megawatt, 10 million euros per megawatt installed, and 50% about this will be dumped into the reservoir development. So this is quite, so 10 millions per megawatt, I'm sorry. So for a 5 megawatt unit, we will have a capex of about 50 million euros. And therefore, you may easily calculate the OPEX is dominated by at least 50% by capital cost depreciation and capital costs.
Fair enough. Thank you for that. And yes, we are seeing a number of questions asking on pricing. So without putting Patrick and Paolo on the spot, I can share at CERC, we're roughly in the US about half of that. So we see $5,000 per kW or 5 million per megawatt as an average. A big driver is, of course, the depth of the drilling. And we have some examples Patrick's company does of some shallow projects, 500 to 1,000 feet production versus the geysers in the Salton Sea where you may be at 7,000 or 8,000. Wells in the Salton Sea are as much as $25 million a well. So the price, for each project is very variable in our experience as well. But I think the benchmark that we've seen for those who are asking is about 5,000 and about 2.5 cents or $25 per megawatt, 2.5 per kilowatt for operations.
Sorry, just one comment. I was when I saw $2,000-3,000. I was referring only to APC above ground. So makes sense with the typical. You have a similar amount for the drilling, depending. Okay, so it's absolutely online.
Exactly, and we've been around drilling two ends of the spectrum in the last year. A New Mexico well that cost under $1 million and a Salton Sea well that cost $25 million. So there you have it, a pretty big range, and it really depends on the resource.
I'd like to add a comment to the topic.
Yeah, please, Taylor.
It's, we've been doing a lot of research into the market and kind of understanding the pain points behind different size developers around the world. And we realized that it's not necessarily the time between drilling wells that causes issues for a lot of these projects that are coming online. But in some cases, it's the time between when a well is completed and when financing is available for the turbine supply or the power production. And on different cases, that could be years where you just have idle wells that aren't producing, that have the capability of producing, but you're waiting for the financing or the turbine to be delivered. And so, I think when we're talking about how do we shorten the time between project inception and power online, it's really coming up with innovative financial models that will come in the form of bridge loans between well construction and turbine supply, or some kind of financing model for based on the feasibility that would be tied to like an integrated package or an integrated solution to supplying the wells, the turbines. And that way you can really shorten the time between start to finish and have your power online quicker, which is a lot more ideal for your cash flow and your projects, and generate a return a lot quicker, and just reducing those gaps of idle time due to CapEx issues.
Thanks, Taylor. Maybe just circling back, Patrick, to you and Paolo, if you could answer quickly. Time to get, again, assuming the drilling is complete, time to get a plant built and installed? Maybe Paolo, to you first.
Yeah. Typically something between 15 and 18 months from order to commercial operation.
Got you. Patrick?
Yeah, I think that's about right. We would say similar. I mean, it can be done a little bit faster. As Paolo said earlier, the biggest thing is getting the reservoir parameters to the design team as fast as possible. So you really do need those few early wells. And again, you touched on it, but if you can find shallow resource, which is why, again, we've been so focused on conventional, though, as you said, also, we do everything from 200 meters to 3,000 meters. That's kind of our typical range for the conventional resources we're developing. But making that drilling go smoothly, getting the reservoir parameters, the design team aligned, and then waiting for permits is a huge one. We could probably conceptually put a project online in 3 years if permitting was fast. I think it's more like 4 or 5 minimum with the permitting structure in the U.S. With so much Western U.S. land being federal, the permitting timelines are quite long.
Right. It's really fascinating for me. I think with Jörg, maybe we're the only two that aren't engaged in manufacturing, so just users of equipment. When we think about the development process, we see in the earlier part of the century, so many projects that raced, often for the wrong reason. Federal grants, the ITC, the PTC, the 1603 program, that raced to size their project, order equipments, and then the resource didn't come through. So it is clearly a balance in getting as much accurate resource information as you can, which is, by default always going to be more time consuming than solar or wind for sure. Well, panelists, we're getting towards the close of our session, maybe around the horn with a 1 minute close. And then if there are any other pressing questions that come in, we might go long. But Jörg, why don't we start with you, if you wouldn't mind?
Well, it has been a very interesting discussion with all of you. And well, geothermal power production from the European point of view, as long as it's subsidized, it will be the bridging technology to roll it out in a wider area for direct use for heat production. I personally expect this will be dominating the rollout in those areas where we do not have the reservoir conditions for power production, saying that we do not have enough temperature or enough flow rate for power production. But I still expect a bright future in those particular areas where we can find these positive reservoir conditions, especially in the Rheingraben. Further projects will be expected in the Bavarian Molasse Basin. Unfortunately, our colleagues in France suffer actually from a suspension of a feed-in tariff being effective from May 1st this year. So there will be no further subsidized power production projects in the Eastern France area, and especially in other areas not to come. Let's expect what the future, especially under the pressure of the climate change politics, have to react against this will bring. And as well, what we need, we have to face raising ambient temperatures, and these will have an influence on the efficiency of our air-cooled condensers. Most sites will not have access to rivers or water cooling systems, so we will have to install air-cooled condensers, and there we need the proper technology to enhance the efficiency of the air-cooled condensers in the future, as probably Ormet already is testing in some sites.
Super, thanks, Jörg. Taylor, over to you.
Sure, yeah, so I'll echo Jörg's comments that this was a really interesting discussion and great panel, and so thank you to my colleagues on here. Overall, I want to echo a point that Patrick said earlier, in that we're entering a geothermal decade. We're entering the glory days of geothermal, and Baker Hughes firmly believes that. And it's not like it happened overnight. It's built off 30 years of work that's been going into getting us to this position. And as a whole, our company is taking a very serious commitment to supporting the growth of geothermal and supporting the industry, both with specific technology investments, financing, capital models, and a lot of exciting things are in the work on our end that I'm excited to tell you guys about when the time comes. But I think you'll be seeing a lot more involvement from Baker Hughes than historically has ever been in the geothermal space, and just working to really support the industry and grow it as fast as we possibly can.
Super, thanks, Taylor, and we're certainly excited about that. Paolo, over to you.
Yeah, thank you, Nick. I think that geothermal still remains a real untapped opportunity, because there is still the possibility to develop huge capacity of geothermal project, as my colleagues told, and this discussion is very interesting. And I'm very optimistic also on the closed loop geothermal new system that are now coming. We have not discussed this topic, but at the end, we are above ground. So we really hope that this closed loop geothermal new AGS system will work well. And with the development and the technology coming from shale gas and the stimulation, and also the money that are really coming to this company now, this can be a game changer in geothermal. We are not actively present, of course, because we are above ground, but we are now supporting these developers and new technology, giving them feasibility and many input of what we can do if they give us the proper heat. So I'm very confident in this, and this can be a game changer, because similar to what happened also in shale gas. Of course, it's a different scheme, but if you invest in this technology, probably in 10, 15 years, I don't know, but geothermal can really become a massive production. Another point, I think that also the combination of geothermal with heat and large heat pump, as we mentioned, especially in area where there is a use of district heating, can really increase the feasibility of the project. Of course, you need to do a tailor-made solution, but in any case, you can have a modular approach. And another point that we have not discussed is the combination also with hydrogen. So I think that geothermal is a dispatchable source, and our solutions are flexible and also dispatchable. But one idea is also to either combine with storage of power, as probably also Ormat is doing. They are investing in batteries. They offer this solution, Patrick can better say. But another idea is to combine with hydrogen production. So especially at the end of the feed-in tariff, because when you arrive at the end of the feed-in tariff, in any case, the OpEx are limited, because all the unit is already depreciated and the underground is running. So if you cannot sell electricity, you, in my opinion, in few years, we want to offer the possibility to produce hydrogen as a new stream of revenue.
Some great ideas there. Thank you, Paolo. Patrick, over to you.
Yeah, so just to echo the others, this has been really interesting, and I'm excited about this week's full conference. So thanks again to the organizers. I think really for me, what the conference is about is continuing to broaden the technical spectrum of what we can do. So like I said, we've done that with temperature. We're doing that with, especially with binary, where we can be more flexible with the temperature decrease that you see over the life of a project. The increased use of pumps, I think, around the world. But really, as you said, Paolo, there's a huge growth in, I would say, conventional geothermal, but also in EGS and possibly others. So, globally right now, I think there's 15,000 or so megawatts of geothermal installed. We see that number really greatly increasing. I think there are tens of megawatts of EGS. We see that increasing. And really what this conference is about is how do we keep making more? How do we keep growing? And how do we do it faster? So I'm excited to see what the others have to say, and excited to continue being a part of it.
Fabulous. Well, I think we're getting some messages that we're just about out of time here. So I want to thank our panel. I want to congratulate our panel. Each and every one of you have been leaders, and your firms have been leaders in your various regions around the world. And I want to applaud that. We need you, and we need more like you to continue to champion geothermal and make these incremental breakthroughs so that we can expand. So thank you for your participation today. To the audience, if you have questions that weren't answered, apologies. We did get quite a number of questions. I'll work with Jamie to provide some answers post the conference. And with that, we will turn it back to the organizers. Thanks, everybody.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.